Hello, everyone. Welcome to this mini lecture. In the last lesson, we learned the fundamentals of images. In this lesson, we will learn about the color modes of images in PS. This lesson focuses on 4 aspects. 1. Learning objectives. 2. Knowledge map. 3. Knowledge points. 4. Summary. First, our learning objectives for this lesson are: 1. Master the RGB color mode. 2. Master the CMYK color mode. 3. Understand the HSB and LAB color modes. This is the knowledge map for this lesson. 1. RGB color mode. 2. CMYK color mode. 3. HSB color mode. 4. LAB color mode. What colors are these 3 circles? Certainly, it's not hard for you. Red, green, and blue. Red, green, and blue are the 3 primary colors of light, forming the basis of the RGB color mode. In RGB color mode, R represents red, G represents green, and B represents blue. RGB is set based on the principle of color light emission. Simply put, its color mixing method is like having 3 lamps, red, green, and blue. When their lights overlap, the colors mix, and the brightness equals the sum of the 2 brightnesses, which is known as additive mixing. In Photoshop, open a file to view its color mode through the image menu and mode option. You can see the image's color mode is RGB. Through the window menu, bring up the info panel and observe the numbers changing next to RGB at the top left of the info panel. When moving the mouse over the screen, the values after R, G, and B change. What do these numbers represent? And what is their relationship with colors? In a computer, RGB color values indicate brightness. Each color is represented by an 8-bit grayscale value. The minimum is 0, and the maximum is 2 to the 8th power minus 1, which is 255, a total of 256 levels, with brightness values increasing from 0 to 255. A color can be expressed using the letters R, G, and B with their respective brightness values, such as R255, G0, B255. Sometimes, for simplicity, the letters are omitted, and it is directly written as 255, 0, 255. Please note that the separator symbol in the middle cannot be mistaken, as it represents the order of RGB. According to calculations, the 256 levels of RGB colors can combine to produce about 16,780,000 colors. So, how do these numbers correspond to colors? Or how can we determine the color from a set of numbers? For individual RGB values, when the value is 0, it means the color is not lit. If it is 255, it means the color is at its highest brightness. This is like adjusting a dimmable lamp. 0 means the lamp is off, and 255 means the brightness is at its maximum. If all RGB values are set to 0, the result is black. If all RGB values are set to the maximum, the result is white. When R and G are 255, and B is 0, the result is yellow. When R is 255, G is 0, and B is 255, the result is magenta, also known as pink. When R is 0 and G and B are 255, the result is cyan. These are the colors when the RGB values are at their maximum and minimum. What if the values are between 0 and 255? How will the colors change? In Photoshop, using red and green as examples. Setting red to 255, green to 255, and blue to 0 results in yellow. If red is reduced from 255 to 200, the color becomes more greenish, which is yellow-green. Conversely, setting red to 255 and green to 200 results in a reddish color, which is orange-yellow. In summary, the larger the RGB values, the more colors are present. The lower the values, the fewer colors are present. You can adjust the RGB values to see how the resulting colors change. Next, let's delve into the HSB color mode, which is defined by the 3 elements of color. Each color includes hue, saturation, and brightness. Hue refers to the basic attribute of color, its appearance, ranging from 0 to 360 degrees, which is the name of the color we commonly use. For example, red, green, and yellow. In the color picker, when selecting H, you can move the arrows on both sides of the strip or enter values in the text box to adjust the hue. Saturation refers to the purity of the color. The higher the saturation, the purer the color, ranging from 0 to 100%. In the color picker, when selecting S, you can move the arrows on both sides of the strip or enter values in the text box to adjust the saturation of the corresponding color. Brightness, also known as lightness, is for controlling the brightness of the color, ranging from 0 to 100%. In the color picker, when selecting B, you can move the arrows on both sides of the strip or enter values in the text box to adjust the brightness. Photoshop's color picker defaults to H, hue, being selected, with the middle strip being the hue strip, adjusting the appearance of the color. In the color field, moving the mouse left or right changes the saturation, and moving it up or down changes the brightness. The choice of color mode when working with an image depends on whether it will be displayed on a screen or printed. RGB and CMYK modes are relatively common. RGB image mode is the preferred mode for editing images, while CMYK image mode is usually used for printing or publishing images, also known as print color. Each letter in CMYK represents a color. C, cyan, M, magenta, Y, yellow, and K, black. Their parameter ranges are from 0 to 100%. Before printing, convert the image from RGB mode to CMYK mode. The LAB color mode expresses a different range of colors compared to the RGB and CMYK modes due to differences in their color gamut spaces and principles. This results in variations between the colors seen on the monitor and those in printed materials. To address this, the International Commission on Illumination established the LAB color mode as a standard for measuring color in 1931. In Photoshop, the L in LAB mode represents lightness, with values ranging from 0 to 100. A represents the component of change from red to green, B represents the component of change from blue to yellow, with values ranging from -128 to 127. The LAB mode encompasses the broadest range of colors, including all colors in the RGB and CMYK modes, making it widely used in color management systems. The LAB mode serves as the intermediate color mode used by Photoshop when converting between different color modes. Finally, let's summarize the content of this lesson. In this lesson, we've covered 1. RGB color mode. R. Red. G. Green. B. Blue. 2. HSB mode. Composed of hue, saturation, and brightness. 3. CMYK mode, a print mode. C. Cyan. M. Magenta. Y. Yellow. K. Black. 4. LAB mode. A standard color mode, used as an intermediate mode when converting between different color modes. All color modes of PS images have been explained. Please complete the following exercises and practice more in your spare time to enhance your understanding and improve your skills. That concludes this lesson. See you next time.